all gathered here for a design thinking based discussion on how to detect cracks in railway track with the help of acoustic sensor. So we've already learned about acoustic sensor. It is capable of detecting and analyzing sound waves in the environment. So here the problem statement is that the proper detection of cracks leads to the safety concern in the railway system. So we are here to identify a better solution to identify the proper crack detection in the railway tracks with the help of this acoustic sensor. So how we use acoustic sensors in the railway crack detection? Okay, because these vibrations or any obstacles leading to the accidents and almost leading to the loss of lives. So we are here to find out a solution by applying design thinking concept. So we know what is design thinking. It is a human-centered approach where we solve the problems by considering each and every emotional needs of the user. So totally there are 5 stages in design thinking. So first is entity, second is define, third is ideate, fourth is prototype, and fifth is testing. So apply these 5 stages and give me a better solution. So I give you 5 to 10 minutes. You can discuss among yourself and give me a solution. Hope you have completed your discussion. You can start providing the solution.
This empathy part. In empathy part, railway authorities they need a reliable and accurate passengers in the train, and they need a safety and a precaution, and they do not have a error. The train should be in a proper good ways, and there should not be any accumulation.
Okay, and next it's a defined phase. And here our challenge is that the railway authorities needed a reliable and accurate directing of cracks and abnormal vibration in the railway tracks. And the manual inspection is slow and costly, and often it's inaccurate. And here we have to prevent the accidents due to these things. So here our problem statement is that how might we develop a acoustic sensor system to prevent these accidents using by detecting the cracks and abnormal vibration on the track. And here the key constraints we look out for are it must work in noise outdoor environment, and it should be low power for remote uses, and it should intelligently differentiate the normal vibration and the dangerous one. This is the most important thing, because in the railway stations or tracks there will be a multiple vibrations that occurring, and we may get confused. So it should differentiate the normal ones and the danger ones, and it needs to scale the long railway distance. So these are the constraints we look out for, and we may take it to the next step.
So the next step is ideate part. From this step we are say about how many ideas we are spending in it. So we use MEMS. MEMS is a micro electromechanical system. It is an acoustic sensor. It will place it in the railway track. Then it will when the rail passes, it will send message to the passengers. Then it may any crack or any issues, it will direct and send to the message to the railway director.
So next to that prototype, and there are 2 components like hardware and software. In hardware, first Arduino or ESP32 use this hardware piece, and after that MEMS microphone, which is used to detect the sound or vibration in the railway track. And after that, if we make a small fake crack in the track, there will be a direction. We can measure the difference by using this MEMS microphone. So
This is what we're going to detect. And for our testing, the LED will blink and buzzer on. And finally, by using mobile phone, the detector get the message and soon as soon the problem will be solved. Thanks.
So the fifth one is testing. So testing is a places of sensors. So it will be environment and speeds are low because they collect the data and storage the information. So but the detects the placements of sensors and the witness and the acoustic. So it will be both hydrations and the feedbacks. So it will be sometimes low and high. So the acoustic sets hydrations and the feedback and the hydrations. So it's both are equal to the acoustic sensor.
So after getting all the results, we have arrived at final solution. So we place our acoustic sensor in railway tracks. It detects any abnormal signals like waveform, vibrations. So after the vibrations are sent to AI or ML models, that will detect it is either it is a normal or a obstruction signal. So after detecting it is a normal or obstruction signal, it will be after the signal will be sent to either railway control centers or mobile phones. So after that, we will know if it is a normal or obstruction signal. We can prevent derailments or else accident. So the major benefit impact of this railway traffic direction network using acoustic sensor is it is low cost and reliable. So it also same as before I said it will prevent derailments and accident.